When you have doubt, please kindly check the playlist for continuation of the session also. And welcome back to the deep learning tutorial. Today we are to see how to classify the CIFAR images with the help of DenseNet 121 model, or you can say how to implement DenseNet 121 model for CIFAR dataset. So since as of you know about CIFAR dataset, that means CIFAR is one of the standard benchmark where we construct 60,000 images generally, and out of 60,000 images there will be 50,000 images utilized for test training and 10,000 images utilized for testing too. And apart from this, the images will be formalized to the size of called 32 by 32 and color images too. So for this one, if you want to implement the CIFAR with DenseNet 120 model, we have to follow some of the steps here. And this is the part 1 video. We are going to just see the part of the things only. Remaining you can see the upcoming session 2 like that. And here first of all we have to install the packages with Python only you can implement. Then we have to load the CIFAR dataset from the online, and we can construct the DenseNet model, and we can go for further construction of after construction of successful DenseNet 121. We can go for further training and accuracy and visualize the images, and that may result at last if you want to confine to also. So these are steps you have to follow if you want to implement the CIFAR with DenseNet 121 architecture. So, and why DenseNet 121 is so important? Because it generally consists of layers, that is dense connected convolution neural network model. Each layer is connected to the previous layers and continuously. And the important of the major motto of using this DenseNet is efficiency as well as the accuracy too. So when you go for the multiple data sets and multiple what are the models you are approaching, from that one DenseNet 121 provide the good results here. So the step number 1, we are going to import the packages, that is NumPy followed by Pandas and OSTime and so on. Then we can go for the options like packages like Torch by default. Then if you want to, and moreover if you have images, CIFAR images, we can go for pre-process. The pre-process done with the help of transform.compose. So the main one for pre-process the image. So because once the pre-process is done, the images comes without noise pollution, noise, then automatically remove the noise, then go for further one with the help of these options only. So from transform to tensor and normalize the images with the options of that 0.5 followed by 0.5, 0.5 and so on. Then we can define the transform for the test, then go for the data loader, and we can go for the CIFAR training loader, then test data loader. Because if any data set you can divide some percentage for training, some percentage for testing too. And after downloading, so this steps helpful to download the data set from the online. So after downloading, you can go for next one, that is class dictionary. And remember, these CIFAR having 10 set of images. Okay, that means each class having 10 classes, that each class having some group of images, maybe 10,000 or 5,000 like that. The classes like airplane, automobile, bat, cat, followed by dog and so on. Then, so if you want to plot the 25 images from the training set, you can write the code called fig, ax, equal to plt.subplot. Then you can write plot.subplot CIFAR 10 images. Then you can write cat, airplane. So if we give the like this, after executing the code, it will visualize the images like CIFAR 10, cat, air, ship, automobile, cat, truck, atlas, what are the images randomly. Then we can go for the class called bottleneck, and we can define the model since it's supporting the Python. And remember, these are helpful for achieve the image classification. Once go for DenseNet, the major advantage is if you want to do image classification like CIFAR dataset, we can go with the help of DenseNet 121. And moreover, parameter efficiency. Once come to the point of DenseNet 121, it support the parameter efficiency too. So after that, we can give the forward option and the class transition option. Then you can go for the forward. Again, give the init cells class DenseNet. So we are creating the class DenseNet, then model. Then after that, we are writing the code self.feature of nn.sequential for everything need for utilize the DenseNet 121. Then So DenseNet 121 in the sense it consists of 121 layers by default. Then we are writing the forward option and make dense layer, and again writing the definition DenseNet 121 activation of relu, and again we are writing the coding, and if you want you can add these layers, sorry, functions. This is the one, and if you want construct the model, you can write the code called model is equal to DenseNet 121. I hope that you understand the part 1 video, that is how to classify the CIFAR dataset with the help of Dens1 part 1 video, and how DenseNet will utilize for image classification. Thank you for watching the video. If you like the video, please subscribe and share with your friends. Thank you.